Imagine asking your AI assistant a question, and before your eyelids finish blinking, bam, you have the answer. Not a half-finished sentence. Not a slowly typing paragraph. A full, structured, elegant response, delivered before your brain even processes the silence. Sounds like science fiction, right? Well, buckle up. Because the future just hit fast forward, and it's called Mercury. For years, large language models like ChatGPT, Claude, and Gemini have dominated the scene. They've written essays, drafted code, built businesses, and even whispered sweet nothings into our ears at 2 a.m. But they've all carried a silent curse, the curse of slowness. Every word they speak, every line of code they produce, it all trickles out one token at a time. Like typing on a typewriter, blindfolded, with mittens. But now? That's over. A new player has entered the ring. One not bound by the old rules. One that doesn't just play the game, it rewrites the rulebook. Meet Mercury. The first AI language model to harness the insane power of diffusion-based generation at scale. And when we say insane, we mean it. Mercury isn't just fast, it's unreal. Try 1,100 tokens per second fast. That's like watching every other AI model in the world stuck in slow motion. And here's the kicker, it's completely free to try. So how did Mercury come out of nowhere and shatter the speed barrier? And more importantly, what does it mean for everyone else? Because if you think AI was changing your life before, you haven't seen anything yet. Section 2, the slow crawl of legacy AI, why everything felt broken. Let's rewind for a moment. Before Mercury. Before diffusion. Before 1,100 tokens per second felt even remotely possible. Most of us have grown used to watching our favorite AI models write like grandpas sending a text message. 1 word. At a time. It's what researchers call autoregressive generation. To simplify, imagine building a sentence the way you build a Jenga tower. Stack one word on another, carefully, slowly, because each depends on the last. One wrong move, one misplaced bracket or verb, and boom, down comes the whole thing. Now, this method has served us well. It's how ChatGPT crafts convincing emails, or how Gemini explains black holes in sonnet form. But it's fundamentally limited. Because each word depends on the one before it, the model can't just blast out paragraphs all at once. It has to tiptoe, like it's writing Shakespeare on a tightrope. Ever wonder why even your snappy AI assistant sometimes feels like it's buffering on a dial-up connection? That's the bottleneck. And it matters. Especially for developers who want real-time feedback. Or companies needing instant analysis on thousands of documents. Or just, you, trying to finish your homework before the pizza arrives. Enter Mercury. Stage right. Wearing rocket boots. Section 3, the secret sauce, diffusion breaks the chains. So what exactly is diffusion? And how the heck did it go from powering image generators like DALL-E and Midjourney, to writing Python functions faster than you can say, for loop? Diffusion, at its core, is like sculpting from noise. You start with randomness, a messy cloud of gibberish. And step by step, the AI cleans it up. Smooths out patterns. Clarifies intent. Refines structure. Until what's left is coherent, compelling, and shockingly precise. Image models have been using this method for years. But language? That's a whole different beast. Why? Because language isn't just about structure, it's about meaning. And preserving meaning while scrubbing away noise requires a whole new level of sophistication. That's where Inception Labs stepped in. And delivered something no one expected, a language model that uses diffusion not just as a side trick, but as its main engine. The result? Mercury doesn't write left to right. It writes everywhere at once. Like an orchestra playing all notes simultaneously, then fine-tuning each one in harmony. It's not typing, it's composing. And because Mercury can revise, polish, and restructure the entire output in multiple global passes, it isn't just faster, it's often smarter. Think of it like this: ChatGPT writes like a student answering an exam question as they read it. Mercury writes like a novelist, seeing the whole plot arc, then diving into write, revise, and perfect. Section 4. Speed isn't everything, let's talk accuracy. Alright, speed demons. Before we go full throttle into the benchmarks, let's ask the obvious question: what's the point of 1,000 plus tokens per second, if half of them are wrong? Mercury's developers knew this. That's why they didn't just build for velocity, they built for precision. Let's talk numbers. Mercury Coder Small, the larger of the two public models, reached 90% on human eval, a gold standard test for real-world Python code generation. That's neck and neck with top-tier models like Claude 3.5 and GPT-4 Mini. Mercury Mini, a leaner, faster beast, still pulls off 88%. On stricter tests like Eval Plus, Small held firm at 80%. And across languages, from JavaScript to C++ to PHP, Mercury consistently matched or beat the competition. TLDR, Mercury isn't just fast, it's dangerously competent. And that changes the conversation. Imagine you're a developer getting instant feedback on your code, without sacrificing accuracy. Or a student writing a script, getting syntactically sound suggestions in milliseconds. That's the future Mercury delivers. Section 5, Real Benchmarks, Real Blazing Numbers. Okay, enough theory. Let's talk raw, brutal numbers. On an NVIDIA H100 GPU, essentially the Ferrari of AI processors, Mercury Coder Mini was clocked at 1,119 tokens per second. Let that sink in. GPT-4 Mini, about 59 tokens/section. Claude Haiku, roughly 61. Even the flashy new Gemini 2.0 barely nudged past 200. Mercury doesn't just win, it laps them. Even better, these numbers weren't cooked up by Mercury's own team. They came from Artificial Analysis, an independent benchmarking lab that measures models under strict, consistent conditions. Translation: no marketing fluff. Just facts. This is what makes Mercury so special. It offers frontier-tier accuracy, with zero compromise on speed. The usual trade-off? Gone. Mercury isn't playing the old game, it's rewriting the scoreboard. Section 6, Developer Paradise, Mercury's API and Playground. Let's say you're sold. You want to try Mercury. Now what? Good news. You don't need to sell your soul, apply for a whitelist, or wait 6 months. Just go to chat.inception.ai, paste in your prompt, and watch magic happen. You can dump in entire codebases, documentation, notes, up to 128,000 tokens of context. That's enough to shove a whole Kubernetes manifest and still have room for detailed instructions. Better yet, it speaks OpenAI-compatible JSON, which means switching your current app to Mercury is basically as easy as changing one URL. It's optimized for GPUs, dynamically adjusts the number of diffusion passes needed, and batches jobs from multiple users so nothing goes to waste. In plain English, it's fast, it's scalable, and it just works. Section 7, What this means for you, and the industry. Here's the truth, Mercury is more than just a faster chatbot. It's a paradigm shift. It proves that diffusion, the technique once confined to image generators, can thrive in language. And that when used right, it doesn't just match the old ways. It obliterates them. Whether you're a solo coder, a startup founder, or a giant enterprise drowning in code reviews, Mercury's impact is immediate. Less waiting. Lower cloud costs. More productivity. Better user experiences. And perhaps most importantly, it democratizes power. If one H100 GPU running Mercury can outperform 10 legacy models, smaller teams suddenly have superpowers. So what happens when this tech spreads? When diffusion becomes the new norm? We might be looking at the next AI arms race, and Mercury just fired the first shot. One last question: if Mercury is this good now, what happens when they drop medium? Or large? That's a cliffhanger worth waiting for. Don't just watch the future, use it. Try Mercury today, and feel the difference. Like, subscribe, and comment your thoughts below. And don't blink, because this future sync tech isn't slowing down.